Hello, hello, hello. Miss Brought here, and we are on page 12 watching video number 30. So we have done a couple different types of factoring. What we're going to do now is we're going to put all those types of factoring together. So we've used three methods so far. Again, we're on page number 12, video number 30. So the first method that we did was greatest common factor. So remember, when we're looking for the greatest common factor, we write out the factors of our numbers. So the numbers that I can divide 4 by and get whole numbers are 1 and 4 and 2 and 12. Oops, can't see that. My factors of 12, I'll write it up here, are 1 times 12, 2 times 6, and 3 times 4. So if I'm looking for the greatest common factor, the highest number they have in common would be 4. If I take a look at my terms, they both also have an x. So when we're taking the greatest common factor, we take the smaller exponent. So we have the second power into the first power. So smaller would just be the x. And then I go ahead and I divide each term by 4x. So 4x squared divided by 4x. 4 divided by 4 is just 1. X squared divided by x is just x. Then I have negative 12 divided by 4, which would give me a negative 3. Remember, we're subtracting our exponents when we're dividing. So 1 minus 1 would give me 0, and that would cancel. So that would be my answer for for the greatest common factor. The second method we have was factoring the difference of perfect squares. So if I was looking to factor this example here, for perfect squares, I do 2 sets of parentheses, one is a plus, one is a minus, and we just take the square root. So remember, the square root of 25, that means 5 times 5. So the square root of 25 is 5. The square root of x squared, we're just dividing our exponent by 2. So the square root of y squared would just be y. Then I take the square root of 81. Square root of 81 is 9 because 9 times 9 is 81. The square root of x to the 8th, I divide my exponent by 2. 8 divided by 2 is 4. So it would be 9x to the 4th. So there's your factoring of perfect squares. And then we did the x method. So we draw a big X. And the constant goes at the top, and we're looking for two numbers that multiply to the top, and then they have to add to the bottom, which is the middle term, that linear term, which is 4. So I'm going to write out my factors of 3. So my factors of 3 are only 1 and 3. Is 1 plus 3 going to give me 4? Yes. So then my factors are x plus 1 and x plus 3. So now we're going to put everything together. So it says, today you will learn method 4, factoring completely. So here's how we factor completely. So the first step is you're going to find the greatest common factor first. Sometimes there will be a greatest common factor, and other times there won't be. So I'm going to do that first for number 1. So my greatest common factor of 2, 6, and 8 would be 2. They don't all have a y, so I can't put y with my greatest common factor. So then I divide each term by that greatest common factor. 2y squared divided by 2 would just be y squared. Negative 6y divided by 2 would give me a negative 3y. And then negative 8 divided by 2 would give me a negative 4. So when we were dealing with just the greatest common factor, we would be done. However, we're adding on now. So after I do method 1, I look and see, okay, do I have perfect squares, which is method 2, or am I going to use the x method for a trinomial? Well, I have a trinomial here, so that means we're going to use the x method. So I put negative 4 in the top, negative 3 in the bottom. I'm going to write out my factors of 4. So I have 1 and 4 and 2 and 2. So if they need to multiply to a -4 and add to a -3, my factors would be -4 and a +1. Because -4 times 1 is -4, and -4 plus 1 is -3. So I carry down my GCF, which is 2, and then I write my factors, which is y minus 4 and y plus 1. All right, I'm going to skip to number 3. So again, we're looking for our greatest common factor first. So my greatest common factor in number 3, I take the smaller of my exponents, which would be z to the second. So I don't have, my invisible numbers in front of these are just 1, so I can put the 1, but you don't have to. Then we're going to divide each term by z to the second. So when we're dividing with our exponents, we just subtract. So 6 minus 2 would give me z to the 4th. And then 2 minus 2. I still need to put a 1 in there as a placeholder because anything divided by itself would be 1. But remember, we're not done yet. So I need to now do either method 2 or method 3. Well, I only have 2 terms inside the parentheses, so I'm going to do method 2 because I don't have a trinomial. So I carry down my GCF. If we're doing method 2, perfect squares, I do 2 sets of parentheses. One's a plus, one's a minus. It does not matter which comes first. And then we take the square root. So the square root of z to the 4th is z squared. And the square root of 1 is just 1. So there's our answer for number 3. We're not going to have you try any on your own, but go ahead and submit this picture into video number 30, please. As always, if you have any questions or need some more assistance, please message your teacher. Have a great day, everybody.